Hello everyone, I'm Shiqi from Southwest Forestry University. The paper I report today is research on face image inpainting based on deep learning. This paper briefly describes the face inpainting technology and summarizes the existing face image inpainting methods. We try to collect most of the face inpainting methods based on deep learning, divide them into attentional, semantic-based, and progressive inpainting networks. Then we summarize the dataset proposed by the predecessors and the evaluation index of the algorithm performance. Finally, we summarize the current situation and the future development trend of face inpainting. Image is one of the common information carrier in all walks of life. Because a large amount of image information is destroyed, editing software can edit image without leaving trace is not feasible. Due to different postures, expressions, and occlusion, face inpainting is a difficult task. Therefore, a good inpainting algorithm should ensure the authenticity of the output, including the topology between eyes, nose, mouth, and eyebrow. Next, I want to introduce a face image inpainting method based on deep learning. With the development of technology has accelerated the development of the technology face inpainting. Some deep learning-based image inpainting methods can already learn rich face semantic information from huge datasets, then fill in the missing information in the image end-to-end, and can achieve better effects. To make full use of the masked information, different researchers have proposed different convolution methods. Freeform image inpainting with gated convolution replaces convolution with gated convolution based on generative image inpainting with contextual attention, while image inpainting with contextual attention and partial convolution is replaced with gated convolution. In addition, image inpainting in the practical application includes freeform or irregular holes. Compared with regular holes, these holes needed different optimization process or attention mechanisms, so an attention-based face image inpainting method was introduced. There are also methods based on semantic. Furthermore, some also proposed to divide the task of image inpainting into several sub-problems for progressive inpainting. The multi-stage network model generally has higher efficiency. In recent years, attention based on the relationship between context and mask is often used in image inpainting tasks. This paper adopts the contextual attention layer method. This is illustration of the contextual attention layer. Firstly, we use convolution to compute matching score of foreground patches with background patches as convolutional filters. Then we apply softmax to compare the get attention score for each pixel. Finally, we reconstruct foreground patches with background patches by performing deconvolution on attention score. The network structure of the first proposed contextual attention image inpainting method is as follows. The two methods use different convolution. In the second stage of image inpainting, the contextual attention module is introduced. In the field of image, semantic refers to the content of the image and the understanding of the meaning of the Face images usually contain unique patterns. When the face image is lost, it's more difficult to complete and restore, which makes face restoration a challenging problem. Because the face image is highly structured and has several key semantic components, such as eye and mouth, it can be repaired better by using the semantic information of the face. This paper adopts the semantic-based method. The face is marked according to each structure through semantic segmentation. The proposed framework for segmentic image inpainting with deep generative modules. Figure is given a GN model trained on real images. We iteratively update Z to find the closest mapping on the latent image manifold based on the designed loss function. Figure B is manifold traversing when iterative updating Z using back propagation. Although some of the above methods have good results, these methods are still challenging for the task of face image inpainting, because the generated image should have a good visual effect and fast processing speed. Therefore, researchers have developed a new method, the progressive-based method, so as to reduce the difficulty of training depth in inpainting network. These papers adopt the progressive-based method. As shown in the figure, many methods use two-stage network structure composed of cores to find networks to repair. In the first stage, the images to be processed are roughly repaired, and then the roughly processed image are used as the input of the fine stage, so as to further strengthen the structure and the texture details of face images. The following figure shows the network of edge-connected and leafing. Edge-connect uses facial contour to repair the image. The incomplete gray image, edge image, and masking in the image are in the other inputs of G1 to predict the complete edge image. The predicted edge image and the incomplete color image are passed to G2 to perform the repair task. Laughing constructs a landmark prediction module on an incomplete face, which reflects the topology, pose, and expression of the target face. In order to repair the face, a repair subnet is designed, which uses the predicted landmark as a guide. The following figure is the results of edge connect and laughing algorithm. A is input image, then is B. The top is present the version of the landmark on the masked image. The low is generated edge, and C is generated result. What I want to talk about next is datasets and evaluation indicators. For face image inpainting, researchers have proposed many public datasets and large datasets to evaluate the applicability of their algorithms. The following table is an introduction to common datasets. CASPIO dataset consists of 99,549 images of 1,040 people with different postures, expressions, lighting conditions, expressions, and whether to wear glasses and other information in a specific environment. ImageNet dataset contains more than 10 million pictures and more than 20,000 categories. Headland Face dataset includes a training set and a test set, all of which are marked with 78 feature points. Caslin Web Face dataset contains 10,575 people. Palace 2 dataset contains more than 10 million images and more than 400 unique scene categories. Celeb 8 dataset contains 10,177 celebrity identities, and each image is marked with features. The above datasets have 4 face datasets, and only one is Chinese face dataset, Shiqi. An example of a common dataset is shown in the figure below. A is Custom Web Face dataset. B is Celeb Face Attribute dataset. C is Helen Face dataset. D is Caspio dataset. E is Place2 dataset. In face restoration, evaluation indexes are usually used to objectively evaluate the advantages of the algorithm. Accordingly, a series of indicators are proposed: structural similarity index and peak signal-to-noise ratio. These indicators are common. SSIM is a comprehensive reference image quality assessment index proposed by the University of Texas at Austin. Is used to estimate the similarity between image inpainting and the original image. This is calculation formula of SSIM. PSNR is the most widely used objective standard for evaluating images. PSNR is used as a measurement method for signal reconstruction quality in the field of image processing. PSNR can be defined by mean square error. The following is the calculation formula of MEM, SE, and PSNR. The evaluation results of some inpainting methods on common datasets are shown in table. It can be seen from table that the values of PSNR and SSIM based on the progressive face inpainting method are relatively stable, and there is no low score, and SSIM almost exceeds 90%. The last part is the conclusion. The task of face image inpainting has attracted the attention of researchers from all walks of life and becomes an important and challenging research topic in the field of computer vision. In this paper, different types of methods are introduced, including attention-based method, semantic-based method, and progressive inpainting method. The commonly used datasets and performance evaluation indexes of face image inpainting in the existing literature are summarized. We make the following prospects for its future research direction and development trend. First, improving the learning ability of image feature expression of inpainting model. Secondly, we need to build a dataset of each surface feature. Finally, generative adversarial network play a key role in image generation. However, at present, generative adversarial network still has its own defects, such as mode collapse and unstable training. How to solve these problems will also become a challenge in image inpainting research. The above is the main content of this paper. Thank you for listening.